Hello, very good morning and welcome back to the electrical power generation and economics subject. We're going to deal with nuclear power plant. This is video number 2 on nuclear power plant. We have already seen the introductory video on nuclear power plant. In this we are going to have more of nuclear power plant after reactor. We'll see this. Dear students, we have seen this in a block diagram. This is your working diagram. You can see and you can analyze how it is actually working. This is your control rods. This is your containment building. This is your containment building. This is your pressurizer. This is steam generator. This is your turbine connecting on same shaft. This is your generator. This is your condenser. This is pump. And this your electricity is being transmitted for the use to consumers. This shows your transmission section. This one is another working diagram showing you the details of the containment building, what is happening in the containment building. You can see the main portion of nuclear power plant is your reactor, where we have fuels, where we have control rods, where we have graphite moderator just to moderate the chain reaction, where we have heat exchanger. See this is your heat exchanger. This is your again control rods. These are your control rods. This is your moderator. The graphite is being used here as moderator. We have seen what is moderator, and we are also going to see in broader way also in this video. This is your moderator, the yellow one, which is going to absorb the extra neutrons, which is going to regulate or which is going to keep these chain reactions under our control. If it is not under our control, it will become a fatal accident, which is certainly not desirable and certainly not required for a healthy society, for a healthy power system to cater to the needs of society. This is steam. Steam being coming out from this containment building or containment vessel. It is going to the turbine. This is your turbine. This is the shaft. This is the shaft. Turbine portion, generator portion. Generator and turbine is connected on the same shaft, and see this electricity is being induced or generated and being transmitted via transmission section. This is your transmission tower. This is your transmission wire, and electricity is being transmitted for the use of consumers. This is consumer base. This is consumer base. From the part of turbine section, this leftover steam is tapped into another module or another section. It is condensed. See this droplets coming out. This is the function of condensers. The whatever steam is left over after losing its heat, after transferring its heat to the turbine section, the leftover water droplets with less temperature content, with very much less pressure, is condensed and back into the system to support the system. This is water pump, and it is going back into the system like this. Fresh water is coming here. This is fresh water. Just to make the condenser process more accurate, more fast. This is whole the function of your reactor. Function of nuclear reactor. Now let us have on the theoretical part of nuclear reactor. A nuclear reactor is an apparatus in which nuclear fission is produced in the form of a controlled self-sustaining chain reaction. Please mark this word, controlled self-sustaining chain reactions. It should be controlled. It should be controlled and self-sustaining. It should be sustained in self such that it should not go beyond the control point, the chain reactions. The classification of nuclear reactor. Goes like, the first one is according to chain reaction system. The first classification is based on, according to chain reaction system, neutron energies at which the fission occurs. First one is your fast reactors, B1 is your intermediate reactor, and the C1 is your slow reactors. Second one is fuel moderator assembly. Under this section, we have homogeneous reactors in which fuel and moderator are mixed. To form a homogeneous material. Second one is, under this topic, is heterogeneous reactors. What are heterogeneous reactors? The fuel is used in the form of rods, plates, lamps, or wires, and the moderator surrounds each fuel element in the reactor core. This kind of assembly or arrangement is called heterogeneous reactors. What are fuel states? Fuel state is obviously solid, liquid, and gas. The type of state of fuel used for nuclear power plant is in 3 states. Obviously it is solid, liquid, gas. We are not going beyond this 3 state of matter. Fuel material, we have already seen this. Let us see it once more. Fuel material is your natural uranium with 235 U occurs in nature. Uranium 235. The second one is enriched uranium with more than 0.71% of uranium-235. This one is another classification of material required. This was another one, and this is another one, which is 0.71% of uranium-235. The C, or the third part of this pure material is plutonium-239, plutonium-241, or plutonium-239. This is artificial or man-made. This is artificial. Natural uranium, that is 0.7%, and its contents increase up to 90% in enriched uranium. In enriched uranium, the content of natural uranium 0.7%, and its contents increases up to 90%. Now, water moderator. Moderators are here used water, that is your H2O, heavy water, that is your D2O, this is like D2O, and graphite. We have seen a graphite based moderator in the start of this video. What is moderator is doing here? Moderator is slowing down the reactions. It is not something like it is going to be uncontrolled. It is controlling. The third one is beryllium or beryllium oxide. Beryllium or beryllium oxide. The fifth one is hydrocarbons or hydrides. Hydrocarbons or hydrides. Now, what are the principal products we are going to use here? The principal product is, first one is research reactor. To produce high neutron flux for research work. The power reactor, to produce heat. This is used to produce heat, obviously. The next one is breeder reactor. What is the function of breeder reactor? What is breeder reactor is doing here? Breeder reactor is producing fissionable material. It's converting fertile material to fissionable materials. It is converting fertile material to fissionable materials. Point 4. That is your production reactor. What is production reactor? It is doing the work to produce isotopes. To produce isotopes. This is important. This is producing isotopes, and the output is radioactive material that is used as a source of radiation and tracers. That is used as a source of radiation and tracers. Coolant. Now come to the next point, coolant, which is very important. Coolant is actually drawing out the heat content within the reactor containment building. This could be air, carbon, and helium cooled. Second point, water or other liquid cooled. The third one is liquid metal cooled. Now let us see the construction of core. The core construction are of 5 types. Type 1, this is your cubical types. This is your second one is your spherical type. Third one is cylindrical type, and the fourth one is slab type, and The fifth one is, so we have seen the constructions type of core. This is the construction type of cores: cubical, spherical, cylindrical, slab, octagonal. Now, let us see the essential component of nuclear reactor. What are those essential components of nuclear reactors? The first one is, of course, nuclear reactor core. The second one is reflector. Third one is control mechanism. Fourth one is moderator. Fifth one is coolants. Sixth one is measuring instruments. And the seventh one is shielding. We have seen the importance of nuclear reactor core. We have seen in the start of this video what core is actually doing, what reactor core is actually doing. Let us once again see the nuclear reactor. This is your cadmium controlling unit. Cadmium controlling unit. This is your reactor moderator. Reactor moderator. This one. Reactor moderator. This one is reactor reflector. This is reactor reflector. Whatever heat is being produced here in this rectangular section, the heat is not actually supposed to go outside from here to here. Otherwise, it will become dangerous. Subsequently, it will become very dangerous. So, there is a shield called reactor reflector. This is actually reflecting whatever heat is radiating from here to back to here, back to here, back to here, back to here. Okay. So it is called reactor reflector. Fuel elements: uranium 235, uranium 235 used here. This is fuel element. This is fuel element. This is your, the black one is your fuel elements. This is your fuel elements. This is your fuel elements. This is the outer shielding. This one is your outer shielding. See this outer shielding. This one is your outer shielding, or simply called shielding. To protect it from outer side, it is protecting, the whole system is protected, or those who are outside this reactor, obviously human beings and all living creatures are being protected from the ill effect of the radioactive phenomena occurring inside this nuclear reactor. Now, this is your heat exchanger system. This is your heat exchanger system. The system is exchanging heat. Where is the heat? Here it is. Heat is there. So water is being sent. Water is, this is water, fresh water. Coolant is being sent. Water is also used as a coolant. We have seen water or heavy water is sent from this channel. This is picking up the heat. This is picking up the heat and coming like this way and crossing this channel. And water in vicinity, in the surrounding of this tube, is gaining heat, and it is becoming steam. It is becoming steam, and steam is channelized to your turbine, generator. After generator we have a power, R, Y, B, and it is big to transmission line. Let us see once again what is happening in the reactor core. We have seen the block diagram just now, and this is the live diagram or live working diagram of reactor core. By seeing this, you can have a visualization of the system in a better way, and you can explain in your own words. This is your control rods. This is your fuel rods. This is your fuel rods. This is your primary coolant. Here it is primary coolant. Pump. This is your secondary coolant. Okay. The steam is coming out like this, going to turbine. The leftover steam is coming to the condenser system. Cool water. This is the shaft, turbine shaft and generator shaft common, and this generator is giving you power, RYB, power, and this is indicating the power is being induced here. Electricity is being induced here, generated here. Now reactor core. This is the main part of reactor, which contains the fissionable material called reactor fuel. It is called reactor fuel. Fission energy is liberated in the form of heat for operating power conversion equipment. The fuel element are made of plate of rods of uranium. Reactor reflect. The region surrounding the reactor core is known as reflector. Its function is to reflect back some of the neutron that leak out from the surface of core also. Control rods. The rate of reaction in a nuclear reactor is controlled by control rods. Since the neutron are responsible for progress of chain reaction, it is suitable neutron observer are required to control the rate of reaction, and it is also for starting of reactor, for maintaining at that level to keep the production at a steady state, and for shutting down the reactor under normal or emergency conditions. Cadmium and boron are used as control rods. This is all about this video. I'll be coming with the next topics, next video. Till then, thank you so much. Thank you for watching this video.